At some AP multiple choice questions that involve derivatives and limits and such. So this first one looks like I'm looking at the limit of this function as x goes to infinity. So it's looks like I multiplied it out at the top, and I have a quadratic over a quadratic, and so I really just looked at the big dog versus the big dog, right? So the negative 2x squared versus x squared, and that ratio is going to be negative 2. This next one just looks like I'm taking a derivative and I use the product rule. This one's a kind of a little intense with the algebra down here, but I use the product rule here. So I took this u times v prime and then v times u prime and added those together, and then to simplify it, I did have to multiply all this out algebraically, combine like terms and such to get their answer D, which I guess is a little annoying. Number 5, I'm looking for the limit as x goes to 0. So in this case, you can either factor out an x squared, and then those x squares are going to cancel, and then you can plug in 0 and just get 8 over negative 16. Or you could apply L'Hopital. Remember, L'Hopital is taking the derivative of the top and the derivative of the bottom. And again, you can't always do that, but you can do it when there's an indeterminate form, like infinity over infinity or 0 over 0. So if you take the derivative of the top and the bottom, I guess you're going to have to end up taking probably like 2 derivatives, and then you can end up canceling. But algebra is always the easiest. Number 6, which of the following statements are true? It does have a limit at 2. It's not continuous at 2 because the limit of the top function is 4. And it's actually the function value at 2 is 1. So if it has a limit of 4 and a function value of 1, then it's not going to be continuous. If it's not continuous, then it's not differentiable. So we're looking at it just having a limit. And again, we can cancel these because we're not letting x equal 2. We're letting x get really, really close to 2. So we're taking the derivative of a trig function here. So the derivative of cosine is negative sine, and then the chain rule gets us that factor of 3 out in front. And then I plug in pi over 9 and do some 30, 60, 90 type triangle to get that ratio. Number 11, which of the following could be the graph of f prime? Okay, so this is the graph of f, and this is the graph of f prime. First of all, this is looks like a cubic, and so we're looking for a positive cubic, and so we're looking for a positive quadratic. So we're looking at maybe, A or B, but we also have to know that this is a positive derivative and then a negative derivative and a positive derivative, and that's what's happening here. Positive slope, negative slope, positive slope. So when the function has a negative slope, the derivative has to be negative. When the function has a positive slope here and here, the derivative has to be positive. So I know it's B. The derivative here. So the derivative of e to the u is e to the u times u prime. The derivative of u, the derivative of 2 over x is going to be a negative 2 over x squared. So that red circle there is u prime, and then of course that's just u. The derivative of f of the natural log of x. So let's take the natural log of x and put it into the function and then take the derivative. Or you can use the chain rule and know that the derivative of f prime of the natural log of x, or the derivative of f of the natural log of x, is just going to be f prime of the natural log of x times 1 over x, the derivative of the inside. So really it's just chain rule, and again, there's probably 2 different ways to think about it. The easiest way probably is to take the natural log and put it in there and then take the derivative of that function. Okay, the key is must be true, and again, must be true is not the same thing as could be true. What must be true, and it does have to have a change in concavity. This has it goes from 5 to 0 to negative 7. So clearly there is a change in concavity on that interval. 6. So we had to do implicit differentiation, right? The derivative of sine is cosine, but then the inside function is xy, and so we have to take the derivative of xy and use the product rule. So it's x times the derivative of y plus y times the derivative of x. But the derivative of x is just 1, which is why it went away. And then over here, the derivative of x is just 1. And so we get this, and then we just do some algebra here. So it looks like I distributed this cosine to both of these terms. I moved this to the other side of the equation, and then I divided by x cosine xy and got this. Okay, so we want it to be tangent. We want this line to be tangent to the graph of this, so to this quadratic. If you look at x plus y equals k, we know that it's got a slope of -1. So really what we need to do is we're going to take the derivative of this. Again, if it's going to be tangent, it has to have the same slope. So we know that at this value, here's the derivative. You want to set the derivative equal to -1 because we want this tangent line to be parallel, or excuse me, tangent to that line. And we found the x value. Once you find the x value, then you can find the y value. But once you know the y value, then you can come up here, and if you know the x value and the y value, you can find k. So that's kind of a geometry, a logic statement that if we know we need a slope of -1, let's find where the derivative equals -1. If we know the x value is -2, let's find the y value. If we know the y value is -1 and the x value is -2, then we have to know what k is. And we can figure out that k needs to be -3. 19 talks about a horizontal asymptote. A horizontal asymptote is we're letting x go to infinity and negative infinity. And so I'm looking at negative infinity and positive infinity here. Positive infinity, this is going to be positive infinity, this is going to be negative infinity, that ratio is -1. When I let x get negative infinity, those both go away and become 0, and so I get 5/1, which is 5. So you're going to have a different horizontal asymptote on the right that you are on the left. Two different horizontal asymptotes. 20, what are the x-coordinates of the point of inflection? Okay, so this is the second derivative. So we are going to have 3 and 6 are going to have a sign change. X squared is squared, so there's actually no sign change at f double prime around 0. I probably should have done a number line here and put in 0, 3, and 6, and you could have seen that the second derivative is positive whether you're to the left or the right of 0. It doesn't actually change. It changes when you get bigger than 3, and then it changes again when you get bigger than 6. Okay, so we know the first derivative, the function's value, and the second derivative, and what is the value of the approximation of that using the line tangent. Oh, so we just got to write an equation of a tangent line. This is completely irrelevant right here. Doesn't matter at all. We're just looking at a point and a slope. That allows us to find the tangent line. The tangent line can be used to approximate the value. All right, we want this thing differentiable. If you want this function to be differentiable, you need to be continuous and you need the slopes to be the same. So over here, I'm setting their y values equal at that x value of 2. So the top function equals the bottom function. And then I want their slopes to be equal. So I set their derivatives equal. So the derivative of the top is c, the derivative of the bottom is 2x minus c. And we want those equal. Again, we want them equal when x is 2. So that's going to end up figuring out what the values for c and d need to be in order for the y values to be equal at 2 and the slopes to be equal at 2. It's really just a system of equations. 26, remember arctangent is just inverse tangent. The derivative of inverse tangent is u prime over 1 plus u squared. So this is an instance where u is 4x. And so there's my derivative, and I'm just going to plug in 1/4 into that. F is increasing. Well, F is increasing when the graph of f prime. F is increasing when f prime is positive. And I don't really give you a choice here, but I don't like the fact that this 1 is there, which is why I think this is the better answer. Because I would claim that at 1, f prime is 0, and it's not increasing or decreasing at that point. The AP and some textbooks kind of skip over that. But I like this answer much better, but clearly they want you to answer B. Remember, function is increasing when you have a positive derivative. Which of the following statements is true? It looks like 1 and 2 are true. It looks like the left limit exists, the right limit exists, but the limit does not exist. Well, yeah, because the left doesn't equal the right. The left limit is here and the right limit is here, and those aren't the same, so the actual limit itself doesn't exist. But the left and the right limit themselves, they agree. or they exist. 78, on which interval is f increasing? F increases when I have a positive derivative. So if I graphed f prime, I'm figuring out where f prime is positive. So on this interval, f prime is positive, that's when f increases. How many points of inflection does it have? Okay, so I was given f prime. You could have taken a derivative and found f double prime and then graphed it, but it looks like I graphed f prime. And then again, I'm looking for when f prime has slopes of 0. So right there and right there and right there and right there and right there. 1, 2, 3, 4, 5. Those are all points where the slope of f prime, meaning f double prime, changes. Positive, or excuse me, negative, then positive, then negative, and positive, and then negative, and then positive. Remember, the slope on this graph is f double prime, and we're asking when does it change sign, or when does it equal 0. So I gave the velocity, we want the acceleration, so just take the derivative and plug in 3, right? So we have position, velocity, and acceleration. They're all related to each other using the derivative. We want, what, x to have a relative max. So right here, water is flowing out. That's a min. Water's coming in, water's coming in. Water stops momentarily, and more water's coming in, and more water's coming in, and boom. Remember, we're looking at the rate. We're looking at f prime, right? F prime is negative here, so water is leaking out of your barrel. This whole time, water's coming in, and then water leaks. There's your maximum. Which of the following could be the graph of x of t, given that? So we want a negative velocity, and then a positive slope, and then a stop, and then a turnaround. That's what this looks like. A negative velocity, a positive velocity, and then a negative velocity, right? These are telling us what the slope should be at that moment of a position graph. The mean volume theorem looks like I quoted that. So it's continuous, and we know that this point and this point exists. If there's no c for which what must be true? Oh, well, if there's no f prime of c equaling 0, then there must be a point where the derivative doesn't exist, right? We could do an absolute value, but the only way to go from here to here without having a derivative equaling to 0 is for the derivative not to exist somewhere, to have basically to have a corner or something crazy happen. Because if something was normal and it would, go up and then have to come back down, or down and then come back up, you'd have to have a derivative equaling to 0. But if you don't have that, well, then this must be true. Okay, f double prime is negative, so my slopes have to be decreasing, right? A negative second derivative is a decreasing derivative. And so I looked at the jumps here. This is a jump of negative 2.5, and then only a jump of 1.5. So it looks like the slopes are decreasing. Okay? And that's what we want. I mean, they're still positive, but they're getting smaller, which means they're decreasing. Okay, that should be it for this year's, I think this is 2008, multiple choice questions.